All right, let's jump right in. If you've ever tried to build a web application, you know that databases are the invisible engines powering, well, pretty much everything. But here's the thing, the web has changed a lot, and the data that makes it tick has changed too. So today, we're going to take a look at a database that was built from the ground up for this new reality, MongoDB.
You know, this quote just nails it. Think about it for a second. Every single time you like a social media post or add something to your online shopping cart, at its core, that's you talking to a database. They are the silent, powerful foundation of our digital lives, and honestly, we almost never think about them.
And that is the billion-dollar question, isn't it? The traditional databases that served us so well for decades, they were designed for a totally different era, for a completely different kind of data. So what happens when the demands of modern apps start pushing those old systems to their breaking point? Well, that's when you get some serious innovation.
This right here gets to the heart of the problem. See, data today isn't just a flat list of names and addresses anymore. It's complex, it's nested. Just imagine a blog post. It's got a title, right, and an author, but it also has a list of comments. And then each of those comments has its own author and maybe even replies. That's what we call hierarchical data. And it is a real headache for older database models.
For the longest time, the go-to solution was the relational database. You know the one. It organizes everything into these super strict tables with rows and columns. And it's a powerful model for sure. But to represent something complex, you have to smash it into pieces and spread it across dozens of different tables. It's a process called normalization. And while it's technically tidy, actually working with it can feel, well, pretty clunky.
And this gives you a perfect picture of that exact problem. Just to get the data for one single blog post, you've got to look in the posts table, then the comments table, then a tags table. They're all over the place. So to see the whole post, your app has to do these complex gymnastics called joins just to glue all that scattered information back together again. Okay, so MongoDB's answer to all this fragmentation is to just think differently. Instead of breaking things apart into tiny tables, it says, hey, why don't we think in terms of documents? And this, it turns out, is a much more natural way to model data, and it looks a whole lot like how developers already work with objects in their code. So what even is a document? Well, you can think of it like a smart container for all the information about a single thing. It uses a structure that's basically JSON, which is, the language of the modern web, with keys and values. But here's the key. Those values can be anything. Simple text, a number, or they can be more complex things like a list of tags or even other documents nested right inside.
And this right here, this is the aha moment. Instead of spreading our blog post across all those different tables, the MongoDB way is to just put everything, the title, the author, the tags, and yes, all the comments, into one single self-contained document. All the data for that one post lives together. In one place, it just makes sense.
Now, this isn't just some neat academic trick. This has huge real-world benefits. The data in your database now looks exactly like the objects in your application code, which just makes development so much faster. You totally get rid of those slow, complicated joins, and because the structure, the schema, is flexible, you can add new fields whenever you want as your app grows. It's a model that's literally built for change.
Okay, so storing data this way is great, but how do you get it back out? I mean, you need a seriously powerful way to ask questions of your data. And MongoDB was designed from day one to give developers all the rich query power they're used to, but built for this new document world.
And this just shows you the difference in a nutshell. On the left, you've got this typical, kind of messy SQL query with multiple joins just to find posts about politics. But look at the right, the MongoDB query. It's this single, simple call that basically says, hey, find me all the posts where the tags list includes politics. It's clean, it's easy to read, and it's incredibly powerful.
All right, so a modern database can't just be fast and flexible. It absolutely has to be reliable. We all expect our apps to be online 24/7. So, how does MongoDB make sure your data is safe and your application keeps running, even when things inevitably go wrong? Well, the answer is a really clever concept called a replica set. The idea is you don't just run one database server, you run a small group of them, a cluster. They all hold an identical copy of your data and they're constantly talking to each other to stay in sync. This creates redundancy, which is just a fancy way of saying if one server fails, your data is still totally safe on the others.
And here's the magic.
In a healthy cluster, you have one primary server that takes all the new data, and a few secondaries that just copy it. Now, if that primary server suddenly goes offline, maybe the hardware fails or something, the replica set automatically holds an election. The other servers vote, and one of them gets promoted to be the new primary. And this whole thing happens in seconds, keeping your app online without anyone having to lift a finger.
So beyond just being reliable, modern apps have to handle crazy amounts of growth. What happens when your app goes viral and you suddenly have millions of users? Your database needs a plan for scaling that won't just fall over under all that pressure.
When it comes to scaling, there are really only two ways to go. There's vertical scaling, or scaling up, which basically means you just keep buying a bigger, faster, more expensive server. It's simple, but it gets crazy expensive, and eventually you just can't buy a bigger machine. Then there's horizontal scaling, or scaling out. That's all about spreading your data and the work across a whole cluster of smaller, cheaper machines.
And that approach, scaling out, is baked into MongoDB's DNA. It was literally designed for a project that needed to scale across tons of machines, right from the very beginning. It was built for horizontal scaling, because that is the only way you can build the kind of massive, global applications we all use every single day.
So let's just pull it all together. It all starts with that flexible document model that just naturally fits the complex data in today's apps. You pair that with a powerful query language so you can find exactly what you need. Then you've got replica sets, making sure your app stays online with automatic failover and an architecture that's built from day one to scale out. It's really the whole package for the modern web.
And I'll just leave you with this final thought, which I think really gets to the core of it all. In our code, we spend all our time working with these rich, complex objects. The big idea behind MongoDB is that our database should be able to handle that richness directly without making us flatten everything into these rigid, boring tables. It's a simple question, but it has some pretty profound implications for how we build software today.